Meta-analyses, or really systematic reviews and meta-analyses. So according to the Cochrane Handbook for Systematic Reviews of Interventions, meta-analyses is the statistical combination of results from two or more separate studies. They have advantages in that they increase power, they improve precision, they have the ability to answer questions not posed by individual studies. They have opportunities to settle controversies arising from conflicting claims. They may be misleading if not careful consideration is given to study design, within study bias, variation across studies, and reporting of biases. Most meta-analysis methods are variations of weighted averages of effect estimates in different studies. The Cochrane Handbook for Systematic Reviews of Interventions is surprisingly accessible. You might think that it is quite technical and a difficult read, but this is one of few handbooks that I feel you could actually read the entire thing and really learn a lot about not only systematic reviews and meta-analyses, but about general study design. Worth getting a copy. It's available online for free, I think. I'm pretty sure it is. And worth reading through for sure. Like a randomized control trial, we should always register our systematic reviews and meta-analyses. It can be done in a register known as Prospero. On the Prospero platform, you can also search for other systematic reviews and meta-analyses to check if there are ongoing reviews that you might collide with. So before you start out, and you might have decided on what you want to do a review of, you should always go to Prospero for searching for other reviews to make sure that you're not duplicating efforts, but also registering your own. There are checklists for writing a protocol for your review, Prisma P. It's called Prisma P. There's a link here. And just like there are checklists for writing protocols for trials, there's this checklist for writing protocols for systematic reviews and meta-analyses. And you can either publish them if you want to, or you could put them on the Open Science Framework or something similar, but make them publicly available in a way where you cannot edit them, so that you, before the fact, decide on what you're going to do. And then once your meta-analysis and systematic review is done, there is guidelines for how they should be presented in a report. These are also, like the handbook, very accessible and really super useful and informative to read. Here I'm going to walk you through just some of the core parts to consider when doing a meta-analysis and a systematic review. This is a text messaging intervention. Well, the idea behind this systematic review and meta-analysis was to look at text messaging interventions for reducing alcohol consumption among harmful and hazardous drinkers. The protocol was published in JMIR, and then the full systematic review, the final report, was published in Addiction here. There are links to the two here. And here are some key points. You have to define an objective. So our objective here was the systematic review and meta-analysis aim to assess the effect of text messaging interventions on alcohol consumption among risky drinkers. The review included reports of interventions that in randomized controlled trials were compared to receiving no or minimal intervention or unrelated health information. So it sets up the whole objective of the review. You need to define your P, your participants. We included trials of risky drinkers, identified by some screening tool in any population, could be students, general population, primary care patients. All of the trials, including them, were included. We didn't put any restriction on age. Trials which included participants who were obviously receiving care for alcohol problems, for instance, patients in treatment programs, were not included. And trials were excluded if participants were mandated to take part. This actually happens, that participants are mandated to take part in trials. And we didn't want to include those. They are severely biased. Interventions, or your I. Interventions consisted of a series of text messages sent to participants' mobile phones over a number of weeks. For an intervention to be included, at least 2 messages should have been sent per week. The content of the messages should be focused on behavior change, etc., etc., etc. You're basically describing what you mean by an intervention that you care about in this systematic review. And then your C, your comparators. Well, in our case, we had minimal or no contact. We accepted trials that use minimal or no contact comparator, including waiting lists, basic health information, referral to information sources, or some intervention that focused on something else than alcohol. Those were the comparators we cared about. And finally, the O, which makes up PICO, our outcomes. We said, well, we are interested in including trials if they plan to report one or two common alcohol consumption outcomes, number of episodes of heavy drinking, and weekly alcohol consumption. So this really defines what we're trying to do and which studies we're going to include in our systematic review and meta-analysis. Then you go through the process of actually identifying them in databases. We found 2,390 records. We removed duplicates. We went through title and abstracts. We found 61 full-text articles that we wanted to read through. 10 of those were included in a narrative review, and then 8 of them were included in the meta-analysis. This is a lot of fun. I have to admit, this is a lot of fun. You then do an assessment of the bias within each study. I'm going to show you the tool in a later session here of how you do this. And you generate this really useful overview of the bias in the studies. So you can see all the red dots here. Each column is one of the studies included, and each row is a domain which might lead to bias. So this domain, which all but one of the studies included failed on, was blinding of participants and personnel. So all studies included in this meta-analysis, except one, had issues with blinding. And that sends quite a strong message when you just look at this, that there is probably risk of bias in the findings of this meta-analysis, because there's a lot of bias or potential risk of bias in the included studies. And then there are other domains such as random sequence generation, that one was fine in all of them, etc. The way we present the meta-analysis itself, that is the weighing of all the studies, is usually done in what we call a forest plot. Here you have, for each row, one of the studies is presented that is included. There is some identifier of the study here. In the first column, you have the number of individuals in the intervention arm or the experimental arm and their average mean score outcome, the standard deviation of the outcome. Then you have the number of individuals in the control arm, their mean scores, and the standard deviation. You then do a weighting of these studies depending on your choice of method. And I won't go into the details, but the math behind this is actually pretty simple. You just basically weigh them up depending on the variation and the size of the studies. And then you get an estimate of the overall effect that we could sort of expect, or the combined overall effect of these interventions. Here it looks like we have a reduction of 0.33 episodes of heavy drinking per month in the experimental arm. There's a lot going on in this figure that I'd like to talk about, but one thing I think is very useful to bear in mind is these up here were small trials which were labeled as pilot trials or feasibility trials. Look at how big the effect estimates are here. This is quite typical in pilot trials that you get large effect estimates. But the larger trials here had more conservative estimates. This is one reason why you should be very careful when planning a trial. It's a good idea to do a pilot study, but don't expect the effect sizes that you see in a pilot study to be anywhere close to what you should expect in a larger scale trial. The final piece of the puzzle in the meta-analysis or the systematic review is to grade the overall evidence that you collected. You should take into consideration the risk of bias. You should take into consideration the risk of publication bias. You should take into consideration if these trials were very heterogeneous with respect to the outcomes, etc. And in our case, we found, for instance, 373 trial registry entries found. Of these, there were 14 entries that were relevant with respect to the eligibility criteria for this review. 8 of these entries were for included trials, and 6 items were for ongoing trials. So based on that, we didn't really find any concern of publication bias. That is, there weren't a bunch of registered trials that never published their findings. If that was the case, we'd be probably concerned with publication bias. Overall, we found the quality of evidence in this meta-analysis, in this systematic review, to be low. Mainly driven by the fact there were few studies, there were a lot of pilot studies that shaped the outcome, and also high risk of bias. A few final remarks when it comes to meta-analyses. Tree plots like these are easy to read, and it might be tempting to open a systematic review and just scroll down to this, because they are very informative. But you need to really understand the whole meta-analysis, the whole systematic review of how it was conducted in order to understand the findings. So make sure you read all the limitations and all of those things, because with great power comes great responsibility. While on the topic of systematic reviews and meta-analyses, I want to make a final remark on publication bias. Whether you're looking for literature for a review or you're just looking for literature in general, you can only find what's there. You can only observe what has been published. What has not been published, and the extent to which it hasn't, creates publication bias. In 1926, Ronald Fisher said, "Personally, the writer prefers to set a low standard of significance at the 5% point and ignore entirely all results which fail to reach this level." Unfortunately, scientists took this to heart and ignored results which failed to reach this level, this quite arbitrary level. This means that a lot of important research which has not reached this holy 0.05 significance level has never been published. Barnett and Wren and Sweet and Cater in these two papers wanted to look at the extent to which this was an issue. Barnett and Wren extracted 968,000 confidence intervals from abstracts and over 350,000 intervals from full-text papers published in Medline, PubMed, from 1976 to 2019. Have a read there. Sweet and Cater converted all of those confidence intervals into Z values, and their distribution is shown in a figure that I'm going to show you in a second. The idea here is that a Z value of +2 or -2 corresponds to the significance level that we are commonly refer to, that is 0.05, a p-value of 0.05. So I'm going to show you this figure now, and I just want to make you aware that you cannot unsee it. Okay? So you've been warned. Here you go. This is the distribution of Z values that they found in these papers. Basically what we're seeing is, you can think of the Z values as p-values if you want to. So a positive Z value of 2, or really 1.96, would be a higher than 1.96 Z value would be a p-value less than 0.05. So here are reports with statistical significance. As soon as statistical significance is not found, their report's missing. So we have a bunch of research that should have been published here but was never published for some reason. Most likely because scientists and researchers have adhered to this idea that as long as you don't cross the statistical significance line, you should ignore entirely all results. This is terrible. This creates a massive publication bias. I want to know about all these studies. I want to know what they were and what their findings were. I don't care if their p-value didn't exceed or fall below a certain threshold. And it's quite obvious that there has been a lot of publication bias going on here. So when you think about searching for literature, and when you think about creating a systematic review and putting together literature for systematic review, bear in mind that there's a lot missing here that you won't find. And all of these should have been contributing to your forest plot, but they're not.